Hello everyone and welcome to day 47 of our low-level design course. Today we are diving into one of the most powerful ideas in system design, designing pluggable and modular architectures. This session will change the way you think about system flexibility, scalability, and maintainability. Let's get started. Before we dive deeper, let's take a quick look at what we will achieve today. First, we will clearly understand what modular and pluggable architectures are and why they matter. Second, we will explore key design principles and patterns that help us build such architectures effectively. Third, we will analyze a real-world case study to connect theory with practice. And finally, we will engage in a fun, hands-on activity where you will apply everything you have learned. So stay tuned. Today's session will be a game changer for your design thinking. Let's begin with modularity. In simple terms, modularity is about breaking a complex system into smaller, manageable independent modules. Each module should focus on a specific functionality, like a well-defined piece of a puzzle. This makes development faster because different teams can work on different modules at the same time. It simplifies debugging because issues are isolated within a module. And when you need to scale, you can scale parts of the system individually rather than scaling the entire monolith. Ultimately, modularity brings clarity, agility, and robustness to your system design. Modularity is all around us, even if we don't consciously notice it. Take USB devices for example. You can connect a keyboard, mouse, printer, or external drive all without shutting down your computer. Each device is a module that interacts through a common interface, the USB port. Similarly, online payment systems are modular. If you want to add PayPal, Razorpay, or Stripe, you don't rewrite your checkout page, you just integrate the module. Microservices architecture takes this even further. Each service like billing, inventory, or authentication runs independently, and yet the system works harmoniously. Now let's talk about pluggable architecture. If modularity is about breaking the system into parts, pluggability is about making these parts interchangeable. Imagine being able to plug new features into your system without having to disturb the existing code. That's pluggability. This requires us to design systems with loose coupling and clear, standardized interfaces. It also demands that we think about dynamic module loading, the ability to add or remove modules at runtime based on configuration or need. In short, pluggable architectures make systems incredibly flexible and extensible. Where do you see pluggable architectures in action? Everywhere. Think about browser extension. You can install an ad blocker, a VIP extension, or a grammar checker without needing a browser update. Your Visual Studio Code editor becomes more powerful every time you install a plugin. In e-commerce, adding a new payment provider like Razorpay or PayU does not break your existing checkout flow. It just adds more options for the user. These systems thrive because they were designed to welcome new functionality without disruption. Now, if you want to build pluggable systems yourself, there are four key concepts you need to master. First, use interfaces and abstraction layers. Interfaces shield your code system from changes in module implementations. Second, apply dependency injection. Instead of hard coding dependencies, you inject them dynamically, making module swapping effortless. Third, think about module discovery. How will your system know which modules are available through config files, registries, or service discovery? And finally, make your system configuration driven. By changing a simple config file, you should be able to add, remove, or replace modules without touching the core code. Get these fundamentals right, and your architecture will be truly plug and play. Certain design patterns naturally align with pluggable systems. The strategy pattern lets you define a family of algorithms or modules and make them interchangeable at runtime. The factory pattern helps you create module instances flexibly without exposing the instantiation logic. The observer pattern is fantastic for event-driven plugins like a new analytic tracker reacting to user actions. And most importantly, the dependency inversion principle reminds us high-level modules should not depend on low-level details. Both should depend on abstractions. When you combine these patterns, your system becomes naturally modular and pluggable. Let's make this more real with a simple case study. Imagine you are building a notification system that supports sending notifications through email, SMS, push notifications, and Slack. How do we design it? First, we define a notification sender interface with a method like send notification. Then we create concrete classes like email sender, SMS sender, push sender, and Slack sender, each implementing the interface. At runtime, based on user settings or configurations, we instantiate use the correct sender. The magic is if tomorrow we want to add WhatsApp notifications, we just create a new class that implements notification sender. No changes needed in the core notification logic. That's truly pluggable. Here's the architecture visually. At the top, we have our core notification service. It does not know anything about email, SMS, push, or Slack specifics. It only knows about the notification sender interface. Underneath, each sender is an independent plugin that can be developed, tested, and deployed separately. This loose coupling and strict separation make the system highly extensible, scalable, and resilient to change. Alright, time to apply what we have learned. Here's a hands-on challenge for you. Design a payment gateway system using pluggable architecture. First, define an interface like payment processor. Then create at least two implementations, say credit card and UPI. Finally, demonstrate how a third payment method like wallet payment can be plugged in dynamically without touching your core code. This small exercise will help you internalize the power of modular and pluggable designs. While designing pluggable systems, be aware of some common mistakes. First, tight coupling. If your code is tightly tied to your modules, you lose flexibility. Second, poor interface design. Keep interfaces clean and consistent. Third, no version management. If you allow plugins, you must manage their versions to prevent incompatibility. And fourth, security risks. Especially when loading external plugins, always validate and sandbox them. Being mindful of these pitfalls will ensure your architecture remains robust and future-proof. Let's summarize the key learnings. Modular systems break complexity into manageable pieces, making growth and maintenance easier. Pluggable systems embrace change by allowing modules to be swept in and out dynamically. Designing for extension, not for modification, ensures that your system can evolve gracefully over time. Remember, software must not just work today, it must adapt to tomorrow's needs. That's the real goal of designing modular and pluggable architectures. For homework, pick a simple monolithic code base you have written, maybe a blog app, a to-do list manager, anything, and refactor it. Break it down into modules with clear interfaces. If you want an extra challenge, add a plugin discovery system based on configuration files. This practice will deeply strengthen your understanding and prepare you for real-world system design challenges. Thank you for your attention.